Hi guys, my name is Sarah Hay. I've been taking this class asynchronously, so you may not recognize me, but today I will be presenting on guinea worm disease. So fair warning for the rest of the presentation, guinea worm disease is a pretty graphic infection, so there will be some pretty graphic photos. So getting into the taxonomy of it, obviously it is a eukaryotic organism. It's a little different from a lot of the other diseases that have presented so far because it's not a virus and it's not a bacteria. It's actually a parasitic roundworm, as you can see in the phylum Nematoda, which includes all the roundworms. And then the class is that of terrestrial parasites. And in the order, it's in with other organisms that are transmitted through copepods, which I'll go into in a little bit more detail later on. But basically, the copepods are called water fleas, and they live in bodies of stagnant water. And through these copepods, which ingest the guinea worm larvae, that is how it gets transmitted to hosts. So for the history of the disease, this parasite's actually been around for a really, really long time. It's an ancient disease. And another name for guinea worm disease is dracunculiasis, which it basically means affliction with little dragons. It was first documented in ancient Egypt in the Ebers Papyrus, which is a collection of medical texts. And that's where they originally described the removal process. It's also thought to be the disease that was described in the Old Testament as descending upon the Israelites when they were on the shores of the Red Sea. It was also documented in ancient Greece by Plutarch and Galen. It was officially named by Galen, and that dracoon part of the name indicates the dragons because of the burning sensation that the blisters formed create in the host. And then it's also thought to be the inspiration for the staff of Asclepius, which is pictured up in that top right-hand corner. You've probably seen that symbol around a lot in medicine and EMS. So Asclepius is the Greco-Roman god of medicine, and that symbol would have been recognized as a healing symbol, specifically in reference to guinea worm disease. It was also documented by Avicenna of Persia. He was the first to clinically document the disease and its treatment. For the pathogenesis and transmission of guinea worm disease, it's a fairly simple life cycle. It is a waterborne disease because the copepods, which have the guinea worm larvae inside of them, reside in stagnant bodies of water. So what happens is the host, usually people, will drink water from an unclean, stagnant body. The water will contain the copepods, which have the guinea worm larvae inside of them. And then once the water has been imbibed by the human host, the copepod dies within the human and releases the larvae. And the guinea worm larvae penetrate the stomach and intestinal lining and will settle in the host's abdominal connective tissue. This is where the male and the female worms will mate, and the male worms will die off, but the female worms will become pregnant and will lie dormant in this connective tissue for about a year. So when the female worm is ready to release her larvae, she will start migrating up towards the surface of the skin. And in about 90% of cases, she moves to the lower body, so that's going to be the legs or the feet. And a blister is going to form right where she's about to emerge. This gives that burning sensation, which the disease is named for, and it's also very painful to the host. The blister will burst in about 24 to 72 hours. And the human host generally re-enters water to soothe the pain of the blister. And the contact with the water actually triggers the female worm to burrow out of the skin and release her larvae into the water. And this causes the cycle to happen again. What is the incidence and the risk of this disease? Well, obviously, it occurs where there isn't access to clean water. So at this point in time, it's really only prominent in the poorest 10% of the world's population. There was an endemic in the 1980s, and specifically in 1986, there's 3.5 million cases across Africa and Asia. However, as of September 30th, 2022, there's only 9 cases worldwide. There's 6 in Chad and 3 in South Sudan, which we will get into more later. It's also a seasonal transmission, which means in dry locations, transmission occurs when it's rainy season, because when it rains, the water collects into a stagnant body of water where those copepods can grow with the larvae inside them. And in wet locations, transmission usually occurs when there's a little bit of a dry season, because the rain stops long enough for surface water to become stagnant, and then the copepods can thrive. It is also most common among 15 to 45-year-olds, probably because they're the most active demographic of people, so they're the ones most likely to be outside, fetching water, doing outdoor activities, bathing in public stagnant bodies of water, etc. Recently, it's been found that animals can also contract guinea worms, especially dogs, and there was a little bit of an outbreak in the guinea worms in dogs in 2012. Researchers are also a little bit concerned that other aquatic animals, such as fish or frogs, could also contract the worm, be unaffected by the worm, and then transmit the worm to other hosts when they are consumed by, say, an animal or a canine. The symptoms of guinea worm disease are uncomfortable. There are no symptoms while the female is pregnant, because she lies pregnant and dormant for about 10 months to a year. As she moves to the surface of the skin and prepares to give birth, the host may experience some of the first batch of symptoms like fever, rash, dizziness, nausea, vomiting, diarrhea. But the most characteristic symptom of the worm is the blister that develops as she gets ready to leave. And you can kind of see that in this photo over here on the left. There's a little bit of a photographic progression of the disease, because as you can see here, there's the blister forming as she moves towards the surface of the skin. And then on the right top photo, that's a picture of the blister popping and the female worm emerging. And then in the bottom, there is a photo of the female worm being wrapped around a stick, which is part of the treatment of the disease. So in worst case scenarios, infection with guinea worm can cause disability. This includes trouble walking or trouble moving certain joints. Interestingly, a study done on the long-term disabilities caused by guinea worm disease found that some portion of those who had been infected with it had trouble moving the joints by their right thumb, which is interesting because a lot of the cases, the female worm exits through the lower body. And very rarely it causes death, but that could be a side effect of multiple complications. As far as treatment goes, there is no vaccine. The main treatment involves a mechanical removal of the worm. So, as kind of described before, somebody would get a stick and physically wrap the worm around the stick, which is also part of the inspiration for the staff of Asclepius, because that image is that of somebody removing the worm with a stick. However, it does not happen quickly. It can take anywhere from days to weeks. And the worst case is the worm is very, very long. So it is a very delicate and arduous process, because the remover doesn't want to accidentally break the worm. If the worm breaks and part of the worm gets left behind in the body, or some of the contents of the worm go back into the open wound, it can cause secondary complications, bacterial infections, and generally not good side effects. This is the main way of treating guinea worm disease. However, it could be supplemented with antibiotic ointment for the popped blister, or accompanied by anti-inflammatory medicine like ibuprofen. So, research efforts for this disease have been extensive. Again, there was an endemic of the disease in certain African and Asian countries back in the 1980s, and President Jimmy Carter, in response to this, founded the Carter Center, which worked in conjunction with UNICEF, which is the United Nations International Children's Emergency Fund, and the CDC, the Centers for Disease Control and Prevention, and the WHO, the World Health Organization, to eradicate the disease. So these organizations work together along with other organizations at local, national, and international levels to work on purging the guinea worm disease from the affected countries. And so through this whole process, they came up with certain criteria to determine if a country was officially guinea worm disease free, and that would only be met when there have been no reports of any guinea worm disease cases for 3 years, because again, the worm lies dormant in the body for about a year, so it would take a while to start seeing symptoms. So since the efforts of the 1980s, we've actually made huge progress in getting rid of guinea worm disease. It's actually set to be the first parasitic disease in humankind that will be completely eradicated. It's also set to be the first disease to be eradicated without the use of a specific vaccine or medicine. And should it be fully eradicated, it will be the second disease in human history that we've fully eliminated behind smallpox, which is very exciting and promising. So what about the disease makes it easy to target, relatively easy to target, and just gives it the potential to be eradicated? It's easy to identify is one of the first and foremost factors. The guinea worm is visible with the naked eye, and blisters are the telltale sign which the guinea worm is leaving the body. So these are things that can be easily seen and theoretically makes them easier to target. We also know that the vector is not airborne. So with bacteria and viruses that are airborne, they're obviously harder to contain. The vector, the guinea worm, for this disease is not airborne. It's limited to stagnant bodies of water. Therefore, it's easier to geographically and physically contain. Interventions are also simple and cost-effective, especially with modern technology and transport. We're able to reach the furthest reaches of the globe that we hadn't been able to reach back in the 1980s. And through that, we can spread life-saving resources to these countries in Africa and Asia that maybe don't have the same resources as a first world country. And some of these can include physical filtration methods to filter out the copepods. Could also include water purification tablets, or a device that's been invented recently is the Life Straw. It's literally a straw, but it allows the user to drink directly out of the body of water, and it filters as the water goes through the straw. We also know that the disease is endemic and transmission is seasonal, which gives the disease some predictability to it because it's limited to certain places, certain regions, and since the disease has been around so long and has been researched extensively, people are able to track when the disease is more transmittable and when it's not. There's also been lots of political commitment to overcoming the disease because there has been the coalition of the CDC, the WHO, and the Carter Fund working together with UNICEF. All these efforts to learn more about the disease and more about its prevention has really brought it to the forefront. And some countries have already completely eradicated the disease, which is promising for other countries working towards that milestone. However, all that being said, researchers do have a little bit of a concern that aquatic animals can contract guinea worm now, and that's something that we didn't really know before, but the fears that fish and frogs and other aquatic animals will ingest the copepods will lay larvae in these animals, and animals will be unaffected, but then humans or other animals will consume the aquatic animals, and this will proliferate the spread of the guinea worm larvae. There was also an outbreak among dogs recently, as I mentioned, within the past 10 years or so. So there have been offered a lot of incentives to monitor the dog's behaviors and not allow them to defecate in public water sources. So these are my references, and thank you for watching.